Hey everybody, hope you had a good break from that last video. So we're going to keep moving on. I think I left you a problem to do that I wanted to see if you had your head wrapped around how the work and force and all that kind of came together. I think the problem was we wanted to lift a 2,500 pound vehicle 6 feet in the air, and we wanted to do it in about 10 seconds. Okay, so I gave you your formulas, so they're all right up there. And so in order to do that amount of work, moving the 2,500 pounds times the distance we're going to move that vehicle, it's going to take 2,500 times 6, it's going to take 15,000 foot-pounds of work in order to complete that task. Now, how much power is that going to take? Because that's what we really want to get down to. How much power in a fluid power system, particularly a hydraulic system, is going to be required to do that task of moving that vehicle that distance in the amount of time? Well, we came up with 15,000 foot-pounds. We divided that by 10 seconds because it's the amount of work over a period of time, which over means divide. So we take 15,000 pounds divided by 10, and we're going to need to do 1,500 foot-pounds per second of, we need that much power, okay? So we also said that we don't really talk about power in terms of foot-pounds per second. We speak in terms of horsepower. Okay, and in order to find the horsepower, we just take the number that we found for our power, which is 1,500, and we divide it by 550. 550 is the constant. It'll always be the constant. So you divide 1,500 by 550, and we wound up with 2.72, almost 3 horsepower needed from our fluid power system in order to complete our task. Now, if you got that, great. If you didn't, and you need a little help with it, back up and review the previous video first. And then, if you still can't get your head around it, come see one of us in the lab, one of the lab instructors or myself. Give me a call or something like that. We'll talk about it over the phone, or we can do it in the lab or whatever. But make sure you're getting this down. This is not going to go away, I promise. This is not one time and you'll see it on the quiz and it goes away. Stay with it, okay, and get it really ingrained in your mind, okay? So let's go ahead and keep moving on. We're wanting to do all this work, okay? So how can we determine, will our system do what it is that we want it to do? So we have all kinds of cylinders and actuators. We're going to have enough horsepower. Can we move things that we need to be moved? Can we lift that bucket of coal? Can we kick a box off of a conveyor, or things like that that the cylinders are going to be required to do? Can we do all that? Well, we don't really know because we still have some more information we've got to get in order to understand this. So I want to back up a little bit. Probably had this in geometry or possibly physical science when you're in school, high school, junior high school. But one of the things we have to take in consideration, and particularly with cylinders that are going to be doing a lot of the work for us in fluid power systems, is the area, okay? Now, just to back up a real quick review, in order to find the area of this square, for example, we're in inches, 5 inches this way, and you have 5 inches this way. To find the area of this square, simply multiply two adjacent sides, 5 times 5, and you wind up with 25 square inches of surface area inside this square box. Now, if it's a rectangle, same thing. You got 7 inches this way, and the adjacent wall is 4 inches this way. You multiply the two together, and you wind up with 28 square inches. Now, we've got it in inches, but it could be in feet, square feet. It could be in square miles, square yards, whatever the division is. You just use the same formula here, but this is for measuring areas that are square or rectangular in nature. Okay, so that's just a quick review on calculating area. And when we talk about square inches, for example, and this we said 25 square inches, 28 square inches. Okay, what is that? We throw that term around a lot. So what does that actually mean? Well, what it means is that if you have a 1 inch by 1 inch, which is a 1 inch square, that is the surface area of 1 square inch, okay? And what that means in relationship to our box here is that we can put 25 of those 1 inch squares inside this square box. And in this one, we could put 28 of those 1 inch squares. So when we say we have 25 square inches, like I said, that's a term we often throw around. I'm going to put 30 PSI in my tire or something like that. We throw that square inch around, but this is literally, it's referencing the area. Okay, so that's where we get that square inch from. Okay, so the number of squares it takes up that you can fit in that square, that's great. But what if it isn't square? Because we don't have square cylinders, okay? The cylinders are round, and there's a way to figure that out, and it's going to be critical that you know it, okay? So on this next slide, I don't want you freaking out or anything. We've got a little bit of math here involved, but I'm going to break it down, and it's really not all that bad, okay? So a lot of you may have not had math in a while, and that's okay. But in fact, I think I read one time that the average student returning back to school has not done any type of real math for about 11 years. So you're not alone. Don't worry about it. We're going to get you through it, okay? But what we're looking for is the area of a circle, okay? We said with 6 by 6 or 5 by 5, we can figure that out in a square. But what about the area in the circle? Because that is going to be our cylinder size, the piston size inside our cylinder. And that's going to help us determine how much work we can do. So let's take a look at how we calculate area, and you're going to see how all this comes out. I'm not trying to teach you math. That's not my purpose here. We're going to be applying this very soon, so hang with me, okay? So we want to find the area of this circle. Just so you know, you can multiply the square of this box here by 78.54 and get the area. Now I'm going to teach you a different way because you're going to need to know this a little bit further down the line. This is a very simple way, and it works well. But I'm going to need to teach you a different way because there's one number that this is not going to help us with, so bear with me, okay? So to find the area of this circle, we need to multiply pi r squared, okay? And there's a lot of good jokes about that, I know. But when you see this symbol pi, okay, that's a Greek symbol, okay? Has to do with the perimeter. But when we see it, all you have to do is replace it with the number 3.1416, 3.1416, okay? So anytime you see the pi, just put that number down right there. R is our radius. Now the radius is half the distance of the diameter, okay? The diameter is from one side directly over to the other side. You cut that in half, that's your radius, but you have to square the radius. And when we say square, we're not talking about multiplying it by 2, we're talking about multiplying it by itself, okay? So if I have a radius of, say I have a radius of 5, okay? I have to square the radius of 5, it's 25, okay? So let's put this into play real quick, okay? So there's our formula, okay? And let's say that we have a radius of 3 inches. Then we say radius of 3 inches because we have a diameter of 6. Remember that the radius is half of the diameter, okay? So 3.1416 times, and when you see these two characters, any characters like that beside each other, that means multiply. It automatically means multiply. So you have 3.1416 times the radius, which is half the diameter, which would be 3. And don't forget, we got to square the 3, so 3 times 3 is 9, okay? So we're going to say 3.14 times 9 gives us 28.27 square inches. That's it. That is the surface area of this circle. And backing up, like we said earlier, that means we could take 28.27, basically 28 1/4 of those little 1 inch squares, stack, you lay them down in here, and we would be able to get 28.27 inside this circle, okay? That is the surface area of our circle, and that is how you figure it out. And it's just that simple, okay? And again, I'm going to just briefly review pi. Anytime you see that Greek symbol pi, that's 3.1416. Take your radius, which is half of your diameter, square it, and multiply it by itself, whatever that is going to be, and then you're going to wind up with the area of the surface area of your circle, okay? All right. For those of you who may have a calculator, this is, I think, very similar to an iPhone or a smartphone or something like that. You can take your radius and hit, like in our previous example, we hit 3, then hit that button right there, it'll square it for you just like that, or you can simply go 3 times 3, 4 times 4, whatever it is, that's how you square, okay? All right, so why is all this important? Okay, I'll give you an example. The area of the cylinder impacts how much work we can do, okay? So we had a car example on a lift, and we're wanting to be able to lift that car, you know, so will this cylinder here do the job? I have no idea. Well, what about this one right here? Big old honking 4-inch cylinder, okay? Will that do it? Well, I really don't know. You might get into a situation where you have a breakdown where you've got a cylinder that's, let's say 4-inch. Let's take 4-inch for example. You got a 4-inch cylinder that works on this machine and does the job. It broke for whatever reason. It's got to pull it out of service and you got to replace it, and you don't have a 4-inch cylinder. Will a 3.5-inch cylinder do? I don't know. You'll know this. You'll know the answer to that question once you learn how to calculate this area and determine whether or not that 3.5-inch cylinder will do the job temporarily until you can get a 4-inch to replace it. Okay? So you might be asked or called upon to figure that out. Well, you're going to know how to do that. Okay? So again, the area of the cylinder impacts how much work we can get done. All right? Now, this triangle here is going to help you figure out the amount of force your cylinder can create. You can use this to determine how big a cylinder you need, or you can figure out how much pressure your system's going to need to provide in order to get that amount of work done. And this is a simple little triangle that works a lot like Ohm's law in electricity. Okay, for those of you who are taking or who have had basic electricity, you've worked with Ohm's law. This works very much the same. Okay, in this case, we've got the triangle with the F on top. That's the force. That is the amount of work we're trying to do. Okay, and then I think your little homework example there had 15,000 foot-pounds. Okay, that's the amount of force that we need. That's what we're trying to move. Okay, all right, and then the area is the area of the cylinder that you just calculated a few slides back. Okay, we just figured out the pi r squared, the area of the cylinder. And then the pressure at which, how much pressure we're going to need if we have a cylinder this size, how much pressure we're going to have in order to move a force of whatever it is we're trying to move. Okay, so these are the three components of this triangle, and they all work together. If you've got two, you can figure out the last one, regardless of which two you have. So let's move forward with that. We had an example. We're going to put a car on a lift. Okay. So we are the amount of pressure that we need, we call that working pressure. That's in PSI. We have the force. That's the amount of work we're going to do in pounds. Okay, and also the area in square inches of the cylinder that's going to be doing that work for us. Okay, so let's put this into play. All right, and again, this is just an example. We've got a 3,200 pound Toyota Camry, and we have a 12-inch diameter lift cylinder coming out of the ground. We're going to use it to lift that Camry or whatever this car is. It doesn't matter. It's just 3,200 pounds. Okay. So again, we're going to use area. All right, to find out what it is we need to find out, because we've been given the diameter and we have the force we're going to try to move, the weight, and it's going to give us an idea of what the working pressure is. Well, we have a 12-inch diameter cylinder, excuse me. And we want to find the radius of that. So we said that the radius is half the diameter, okay, of the cylinder. So that'd be 6. Well, if you remember, we have to take the radius and square it. So it's 6 times 6, which is 36. And remember the pi, whenever you see that, it's 3.1416. Multiply that by the 36. And this cylinder will have 113 square inches of surface area. Okay, and meaning that you'll have 113 of those 1-inch squares in the surface area of that cylinder. Okay, so that our fluid can push on 113 square inches of that cylinder and lift this. All right, so we've got 2 now of our 3 components. We've got the force, and now we have the area. Okay, of 113 square inches. All right, and what we can find out now is, if we use our formula, we have the 3,200 pounds. Then the 113 square inches of surface area in our cylinder, we're going to need a total of 28.31 psi on that cylinder. Okay, in other words, we're going to need 28 pounds of pressure behind each one of those squares in the cylinder. Okay, that gives you a visual of what's going on there. Okay, so we wound up with the force, we had the area, we found out the pressure. So we had 2 of the components, we were able to find out the third one. Okay. And again, this is the squares. This slide just shows you the squares in the surface area of the cylinder. Okay. So that gives you an idea of how to figure out the surface area of a cylinder, and you're starting to understand now the importance of why this is. It's not just a math lesson. This is going to enable us to calculate and figure out our system pressures what size components we need. Can our system do what it is we need done? So I'm going to stop this video for right now. We're going to pick up here in just a second with the next installment. But again, if you have any trouble with these calculations, come see me and we will work this out and make sure that you're on the right track. Other than that, make sure you tune into the next video, and thank you for watching.